Welcome, and here we go. Surface areas of volumes and the surface areas and volumes of spheres. And today you will find the surface areas and volumes of spheres. Anyways, let's look, shall we? Okay, so here I just wanted you to see some ideas that we'll talk about with the sphere. Of course, you have your diameter, you have your radius, you have a tangent and chord, but basically we're going to focus mostly on the radius and kind of going from there. Now, let's try that again. The formulas are fairly simple. They're just 4 times pi r squared, and the volume is 4/3 times pi r cubed. And I will show you how to get a cube on your calculator. Anyways, so here we have an example. Okay, notice that the radius of this sphere is 6, and I want you to find the surface area and then also find the volume. So the surface area would just be 4 times pi times 6 squared. Which, if you do that, you should get roughly about 452.4 centimeters squared. The volume, or square centimeters, is 4/3 times pi r times 6 to pi 6 power cubed. Okay, anyways, 4/3 times pi times 6 cubed. I was going to get that right in a second. And that would give you, if you plug that into the calculator, 904.8. Again, nothing super difficult, fairly simple, kind of go from there. Now, I do want y'all to know, we can have planes intersect spheres at different points. For example, if you saw this, like the spheres at HEB, they're not true hemispheres, but they are cut off because they have a flat bottom. Otherwise, the spheres would keep rolling. But when you have, say, one that's perfectly in half, we have what is called a hemisphere. 2 congruent halves, where it's cut completely in half. That one has a slightly different surface area. Now, there is a way to simplify this a bit, but we're going to keep it like this, because I think this would just keep it, what's the word? It would keep it easy, per se. All right, so how can I do this? All right, so I have this hemisphere right here. It has a radius of 2.8, so I'm going to take half of the surface area of a regular sphere, so 4 pi times 2.8 squared, but I'm going to still add the area of a circle, because that circle on the bottom is still going to be there. And when you do that, you get 73.9 centimeters squared. The volume would be half of the 4/3 times pi r cubed, which, according to that would give you 46.0. It actually came out to 45.97. 7 makes the 9 go up, so 46.0 at centimeters cubed. So that cubic centimeters. Okay, so that one, you can see how that works. That's all there is for surface area and volume. How can I make this tricky? Because this is supposedly way too easy. Well, what happens if I gave you a circumference of the sphere? As basically a circumference at the great circle, which means it goes through the diameter. It goes through the center. Okay? Well, keep in mind that a circumference of a circle is 2 pi r. So if I put 5 pi in place of the circumference and say 2 pi r, and I want to find the radius, I need to divide by 2 pi. And then that would give me 2.5, which I could plug into my surface area and volume formulas. So on this one, I would get about 78.5 for the surface area. Centimeters is centimeters. This is meters squared. Okay. And then for the volume, again, 4/3 times pi times the 2.5 raised to the 3rd power. And that would give me approximately 65.4. We'll say 65.4 cubic meters, or meters cubed. And that's really about it, guys. It really is nothing that should be that difficult. Should be fairly simple. There you go. Not sure exactly how I can make that more hard, but okay, that's it. Thank you so much for your time. Y'all take care. Keep it up.